The first step in making a gypsum board is extracting gypsum from massive mountain ranges, where this mineral lies deep underground and can only be accessed through large open pit mines. Powerful drills bore holes dozens of meters deep, creating shafts strong enough to hold explosives. Specially designed charges for mining are packed deep into the rock so that, when detonated, entire layers of gypsum break free from the mountain. Thanks to these carefully calculated blasts, the mineral is released and made ready for the next stage of its journey, becoming an essential material in modern construction. After that, once the signal comes from the chief supervisor, the blast is triggered, sending thousands of tons of gypsum crashing free from the mountainside. Massive excavators move in on the piles of freshly blasted gypsum, scooping up chunks that weigh several tons at a time. Each machine works in rhythm, loading the mineral into the beds of smaller, specialized trucks. These trucks rumble down dusty paths, carrying the gypsum to a temporary staging area. There, the loads are transferred once again, this time into giant, heavy-duty haulers built to handle massive volumes. From that point, the gypsum begins its journey to the processing plant, where raw stone will be transformed into a material essential for construction. Thanks to its steady motion, the crushing energy is used efficiently, making the size reduction more effective. The result is a continuous flow of crushed gypsum pouring out from below. These gypsum rocks contain as much as 70 to 80% pure gypsum, and they're crushed down into particles only a few millimeters across. Once the gypsum is finely ground, it's carried onto massive conveyor belts that move deep into the plant. These belts stretch hundreds of meters long, running non-stop at a steady pace to keep the flow of material uninterrupted. Thanks to the automated transport system, every particle of gypsum is delivered straight to the drying and processing area for the next stage of production. After grinding, the fine gypsum powder is fed into a giant rotary kiln for the heating process. During this stage, calcium sulfate dihydrate slowly loses water and transforms into calcium sulfate hemihydrate, commonly known as calcined gypsum. Flames from the burner shoot directly into the kiln, creating temperatures that range from about 300 degrees up to over 660 degrees, with some hot spots reaching close to 600 degrees. The heating usually lasts for hours, allowing the water to be released gradually so the crystal structure doesn't break down too quickly. Engineers carefully monitor and adjust the controls, keeping temperatures steady in different zones of the kiln. This strict level of control produces high-quality gypsum powder, ready to move on to the next mixing stage. Once the heating process is finished, the gypsum powder is sent to the mixing area to be prepared into slurry. Before blending the entire batch, technicians take a small sample to the lab for testing. There, the powder is mixed with water in a set ratio and combined with additives like starch or setting time modifiers. The mixture is stirred thoroughly, then monitored for expansion, strength, and setting time. Results are compared against the required quality standards, helping engineers confirm the stability of each production lot. Thanks to this testing step, the plant makes